This section is all about the way Duchenne is inherited through the generations. We will also have sections on who carriers are and how the condition affects them. Genetically inherited conditions are complicated and often bring up difficult thoughts, emotions and feelings. Here at Action Duchenne, we advocate for those affected to talk to genetic counsellors where possible. We would also encourage you to always reach out and get in contact with our support team if you or someone you know could benefit from some guidance around this topic. Thank you.
So Sophia, have you ever wondered why Duchenne muscular dystrophy mostly affects boys? And when we refer to Duchenne muscular dystrophy, we mostly talk about boys. I mean, it can affect girls, but why do we mostly talk about boys?
Well, Maureen, that is a very good question, and it has something to do with the way the condition is inherited, because we know that Duchenne muscular dystrophy is linked to the X chromosome, and girls have 2 X chromosomes and boys have 1 X chromosome and 1 Y chromosome.
Yeah, absolutely. Duchenne muscular dystrophy is indeed linked to the X chromosome, one of the 2 sex chromosomes that determines our biological sex. It is fascinating how genetic plays a role in the inheritance patterns of certain conditions.
Yeah, and we know that Duchenne is passed down differently between males and females. Would you like to elaborate on this a little bit more, please?
Yeah, absolutely. So X-linked inheritance is the key here. Since Duchenne is caused by mutation in a gene located on the X chromosome, the inheritance pattern follows a unique sort of pattern. Only a mother can pass her X chromosome to her son. And if that chromosome has a mutated gene, then a son will develop Duchenne. So what I'm trying to say is, in order to be born a girl, you'll carry an X chromosome. In order to be a boy, you will have 1 X and 1 Y chromosome. So the mum can only pass on the X to her boy, and the dad can only pass on the Y to the boy. Because if the dad passes on the X, that's going to be a girl, because it's going to be X and X. So when the mum passes on the X chromosome and the dad passes on the Y chromosome, you're born a boy. And as we already know, the gene or the recipe manual for making dystrophin is only found on the X chromosome. So that child, that boy, has an X with a mutated recipe or a change recipe or gene for making dystrophin, so X and Y, and he's got a Y which has nothing to do with the recipe or where it sits. So that is why you'll have boys who are affected by Duchenne muscular dystrophy. And on the other hand, I was going to just add, on the other hand, you've got a girl who's got an X and X chromosome. So she's got an X chromosome from her dad and an X chromosome from her mum. And let's say the one she's got from her mum has the mutated gene on it. So then that girl is known as a carrier. Does that make sense?
Yes, that totally makes sense. And because males, they have 1 X chromosome and 1 Y chromosome, they only need 1 copy of the mutated gene on their X chromosome to develop Duchenne muscular dystrophy. So if the father has this mutation on his X chromosome, there is 50% chance of passing it to his daughters. But here, it's getting really interesting. And I think it's about a fascinating fact about the X-linked inheritance. Men with Duchenne, they will never pass Duchenne to their sons. They just physically cannot do it, because when a man has a son, he always passes his Y chromosome. And if the boy has, or a man has Duchenne muscular dystrophy, it sits on X chromosome. That's why they cannot pass it to their sons.
Absolutely. And that is really interesting, because fathers, like you said, can only pass on the Y chromosome to their sons. So they, genetically speaking, if the condition is on the X chromosome and fathers are only passing on the Y chromosome, then the X is not going to be passed on with the faulty genes. So the sons of men who have got Duchenne will never have Duchenne. However, if men with Duchenne have a child with a DMD carrier, someone who's a carrier, which is X and X chromosome, a female who carries the mutation on one of her X chromosomes, then they will have children who are affected by Duchenne. So because, but to be very honest with you, Sophia, that's just us talking science. But with the advancement in sort of genetic tests and counseling and understanding more about how the condition is passed on. I think that is pretty rare to sort of, it's very unlikely we'll ever see that happening. But it's just really interesting point to say that, boys or men with Duchenne will never pass on the Duchenne to their boys, because they just pass on the Y chromosome and then the X gets left behind.
Yeah, exactly. There are so many advancements in science, and the genetic counseling is very crucial when Duchenne individuals are planning their families. And I just want to emphasize that these X-linked inheritance patterns are so precise, and it's so important to talk about them. And going back to daughters who inherit the mutation, so I just want to say that they won't develop Duchenne muscular dystrophy, but they will be carriers, meaning that they will have that one X chromosome that has a mutated gene on it.
Yeah, exactly. So daughters who inherit the mutated gene are known as carriers, which is literally they carry the mutation in one of their X chromosomes. So you have two X chromosomes. The daughter will take one from the dad and one from the mum, and one of them will have the mutation in it. So it means that they carry the gene, but carriers don't always show symptoms of Duchenne muscular dystrophy. There's so many carriers we've met who never knew they were carriers actually till their son was diagnosed. So not every carrier displays symptoms of Duchenne muscular dystrophy. However, they can potentially pass on the mutation to their own children, which is why it's so important to bring in genetic counseling and tools to understand understand your diagnosis and the care pathway that you should follow. And that's why it's really, really crucial.
Yeah, absolutely, Maureen. I just want to explain what happens and what is the percentage of the chance to have a kid affected by Duchenne if a mother is a carrier. So if the mother is a carrier, meaning that one of her X chromosome has a mutated gene, the inheritance pattern becomes more complex. So a carrier mother has a 50% chance of passing the mutated gene to both her son and her daughter. So her son, who receives the X chromosome with a mutated gene, he will develop Duchenne muscular dystrophy. But the daughter will be a carrier who will carry the X chromosome with the mutated gene. However, there is also 50% chance that she will get unaffected daughters and unaffected sons.
Yeah, I mean, females have two X chromosomes. So if one has a mutation, the other serves as a backup copy where a body can get genetic sort of recipe to make protein. So for example, so daughters who are carriers, they've got two X chromosomes, right? But both the X chromosomes carry the recipe for making dystrophin protein. Okay, fair enough. One of them is faulty. One of them has a mutation, hence she's a carrier. But she's actually got a backup copy of the X chromosome, a backup copy of the recipe on the other X chromosome. So she can carry on making sort of dystrophin protein.
Yeah. Oh, I just want to add one interesting fact. So there are females who have Duchenne muscular dystrophy, like full-on condition. However, it is extremely rare. And I think we looked at the numbers in the papers and it says that it's less than 1 in a million. So very, very rare.
And you know why that is because, like I just said, a female who's a carrier, she's got two X chromosomes and one of them has the genetic mutation and one of them doesn't. They both have the recipe manual or the gene for making dystrophin. So in a carrier where you don't display the symptoms of Duchenne, it could be just that the recipe is being read from the X chromosome that doesn't have the mutation in it. So the healthy X chromosome is being read. But there's nothing in our body, or there's no way medically we can tell the body which X chromosome to read. We can't say, don't read the faulty one, read the one that doesn't have the fault, the mutation in it. So naturally we can't. Some women, you could have two carriers sitting next to each other in a room, and one of them will say, I have no idea I'm a carrier. I sometimes think I ran too much, that's why my legs are hurting. And the other one would say, I cannot walk a couple of steps without getting breathless. I need sort of cardiac assessments regularly, etc. So they both have two X chromosomes and they both carry a mutation in one of their X chromosomes. It might be that the faulty X chromosome is being read by the body more in someone who's actually displaying the symptoms of Duchenne, or has symptoms, and the other one, the other female, her non-mutated X chromosomes being read. And it is quite fascinating how the inheritance of Duchenne follows a distinct pattern based on the X chromosome, hence it's an X-linked condition. And I think understanding these inheritance patterns is absolutely vital for families and individuals to make informed decisions and seek the appropriate medical care.
Yeah, and actually we were talking about females who have Duchenne muscular dystrophy at one of our workshops, and what one case scenario we were discussing is that why they might get Duchenne muscular dystrophy is when the father will be affected by Duchenne muscular dystrophy and the mother will be a carrier. In that case, when they are passing both, they will be passing their X chromosome with a mutated gene. They will have a daughter who will have two X chromosomes with mutated genes. And in that case, when the body, doesn't matter which chromosome it scans, it will still get the faulty information and it will get the dysfunctional dystrophin protein. So that was one of the, I don't know, speculations we had at the science workshop. But yeah, it's definitely extremely interesting how these X-linked patterns are happening and all the science behind it.
Yeah, absolutely. And I'm I would like to just emphasize that with these better diagnostic tools and genetic counseling and tools available, we are now able to screen people. And so, for example, a man with Duchenne, his partner will potentially be screened to make sure she's not a carrier. So that minimizes, passing on Duchenne to the children. So I think these kind of tools, smart tools we have are really, really sort of important and impactful.
Yes, absolutely. And it's just so fascinating to watch Duchenne families having their own families. And it's just so good to have all these tools and to realize that they are effective and they are helping people to make families.
Here at Action Duchenne, we are committed to inform, but also support you through your Duchenne journey. If you'd like to talk about anything raised in this video, please feel free to contact us on 07535 498 506, or alternatively email us at info@actionduchenne.org. Thank you.